Okay, so let's look at graphing functions. The previous chapter we kind of looked at functions, but now we're looking at graphing those functions. So what types of functions? So we met with linear functions, and they are of the form y equals ax plus b, i.e. something like f of x equals 2x plus 3. This is the slope, the rate of change of y with respect to a 1 unit change in x. This is where a plot of the graph 2x plus 3 would intercept the y-axis at y equals 3. And just to remember that when we have input values for x and we put them through the function, we get our output values, or these y values, that the first difference between the y values is constant. Okay, and that difference is known as the slope of the plotted line. And then we also met in this chapter the idea of proportionality, and we said that a graph or a plot of a function, that function is only proportional if the plot goes through the origin 0, 0. It's a straight line linear plot, and the ratio of the x to y coordinates is constant. So here we can see that 4 divided by 1 goes 4 times, 8 divided by 2 is 4, 12 divided by 3 is 4. So that's they are proportional, the x's to the y, whereas here we have 1 goes into 2 twice, but 2 doesn't go into 3 twice, and 3 doesn't go into 4 twice. Okay, so that's not proportional. I suppose a quick check is to say, what is y divided by x? It's 4. Is that true for all of these? Yes, it is. What is y divided by x here? It's 2 divided by 1. It's 2. Is that true for this? 3 divided is not 2. 4 divided is not 2. So no, not proportional. Then we met with the intercept method, which was basically gives a way of finding a quick plot of a graph. So if we were given a function, it's not always going to be given ax plus b, but if we're given a function 3x plus 2y is equal to 6, if we were to let x equals 0, we'd find a value for y, we'd have an y coordinate, 0, comma, whatever the y coordinate is. If we let y equals 0 and then put that in here, we'd find a value for x, we'd have a second coordinate or a second point, and we could quickly plot those 2 points. Okay? Just to recall, or just to note that intersections, okay, if we're given a function, one function f(x) plus 1 and a second function g of x equals 2x minus 2, then those, if we were to plot those two functions, those two lines, they would intersect at that point where f of x is equal to g of x. They would intersect at an x value for which into both functions would give us an intersection. So how do we find that x value? Well, we say we let one function equal the other and we solve for x, and then we put our x value equal to 3 into the first function, and we can find our y value, or our f of x value, y equals 4, and we can see that our intersection of this function and the second function is at the point 3, 4. Okay, so we let x plus 1 equals 2x minus 2, x equal to 3, and then we simply sub x equal to 3 into any of the two functions, but into this one it gives us a y value equal to 4. And what kind of functions are we graphing? The second type then is the quadratic function. It's in the form f of x equals ax squared plus bx plus c. Quadratic functions always generate parabolas. Okay, if a is positive, it's U-shaped. If a is negative, it's N-shaped. And to find the axis of symmetry, given the form of the equation, we can find that value of x, which acts as the axis of symmetry, by simply using the simple formula x is equal to minus b over 2a. i.e., if we have a function 3x squared plus 18x plus 6, the axis of symmetry at the x coordinate is equal to minus b, it's minus 18, over 2 by a, which is okay, sorry, just realised an error there, but we'll carry on. If we have a function 3x squared plus 18x plus 6, to find the axis of symmetry, we use the formula minus b over 2a. We use the formula minus b over 2a. So that would be minus 18 over 2 times 3, which is 6. So it's minus 18 over 6, so our x value is equal to minus 3. So our axis of symmetry here is that x equals minus 3. So minus 3. And then to find the minimum value, the minimum turning point, the y value, then we sub x equals minus 3 into our function here. So we would have y is the f of x, sorry, is equal to y. So our y value is equal to 3 by minus 3 squared plus 18 by minus 3 plus 6. So that's equal to minus 3 squared is 9, 3 by 9 is 27, minus 54 plus 6. And that would be equal to y equals minus 21. So this is y equals minus 21. And now if we just look at a graph, just remember, and you learned this in first year, that this is the x-axis, this is the y-axis, and if we were to strike a line through y equals 2, that's the line y equals 2, but it's also f of x is equal to 2. And if we were to strike a line through x equals 1, that's the same as f of 1. Okay, and any piece of a plotted graph above the x-axis is known as the positive portion, and any piece of a graph that's below the x-axis is known as the negative portion. And in this chapter, really, you're given a function, you plot it, and then you're asked to find f of x equals 0 or f of 1 and so on. And basically, you're plotting a graph, and you're then, plotting lines through the graph like f of x equals minus 2, and you're finding what those values are, where the line you've drawn and the graph you've plotted intersect. Where does that line cut the graph? And you're finding the values along the x-axis for that particular case. Or you might be asked to find f of 1, so you draw a line at x equals 1, you see where it cuts the graph and you find the corresponding y value. So for example, f of x equals 0, that's the x values where the plot cuts the x-axis, that's a and b. This is, the x-axis is the same as f of x equals 0. F of x equals minus 2, you go down minus 2, y equals minus 2, and you find where it plots the curve, where it cuts the curve, that's at c and d. Or you might be asked to find f of 1. You might be asked to find f of 1, and f of 1 here, we plot a line. F of 1 is actually the x equals 1 line, and we see where it cuts here, and that's at E. Cuts the y-axis at E if we bring the line across. Okay, and this method applies for any type of plot of a graph or function. Where do graphs intersect? Okay, we plot a graph, quadratic, x squared plus 2x plus 3, that's a parabola, that's this shape. Here's a line, g of x equals x plus 2, we plot that. Where does f of x, where does the quadratic equal the line? Where is f of x equals g of x? So it's the x values where the line cuts the quadratic. So if we strike our line through, cuts the quadratic at A, that's one x value, and at B, that's another x value. And here, where, look at this problem here, or sorry, look at this little piece to make note of, where this is f of x, this is a parabola, this is g of x, a straight line. Where is f of x less than g of x? It's less of g of x when it's below the line. Okay, the parabola is less than g of x below the line, and it's greater than g of x above the line. Okay, so that's between the points C and D. F of x is less than g of x between x at C and x at D. Okay, so it's all the x values between C and D, produce a plot of a quadratic under the plot of the line. So here's an example, a real example. Plot the function x minus 3x minus 4 in the domain, i.e. from x is minus 2 to x is 5. And we use our calculator. So in our calculator we hit the mode button, 3 for table. We put in our start minus 2 equals, and then we put our end 5 equals. And we put our step 1 and we type equals, and that generates the table of couples or points that we need to plot. Plotting those gives us this quadratic here, okay, so our quadratic, and then we're asked, say, to find the minimum point. We'll find the minimum point, use the formula minus b over 2a, so it's minus 3 over 2 by 1, which is 2, so it's 1.5. So you can see x is 1, x is 2, x is 1.5. That's the axis of symmetry. To find the minimum value here, where is that minimum value? Minimum turning point, we just put x is 1.5 back into here, and that gives us minus 6.25. That's the minimum turning value. Find f of x equals 0. This is f of x equals 0. It's actually the x-axis, so it's this x value and that x value. Okay, and we could also, so we get that as minus 1.2 here, and 4.2 here. Okay, we could also find the factors of the equation here. That's minus 1 and 4. Sorry, f(x) equals 0, and we could also have got that by just finding the factors of x squared minus 3x minus 4 equals 0. Minus 3x minus 4 equals 0. Just to find the factors of the equation, okay, mathematically. But this chapter is about plotting the graph and reading from the graph. What about f of x equals 1? Well, if that's f of x equals 0, this is f of x equals 1. We're looking for these 2 points here, where f of x equals 1 cuts the parabola, okay? And that is at minus 1.2 and plus 4.2. Okay, f of x equals to 1. Now we could have let our function equal 1, f of x equals 1, and bring the 1 over, and we get a new function, x squared minus 3x minus 5. If you put that into the quad formula, you would get x is minus 1.2, x is 4.2. That's doing it mathematically if you wanted to. Now, what about if we were added to add in or plot a function g of x equals x plus 1? Well, if we were to find the points of that using our calculator, we would plot this line here, okay? And to find f of 1, that's the same as before. We just go out to x is 1, and we see where it cuts the parabola, and it's at minus 6. To find where f of x is less than 0, it's wherever this function is below the line, and that's x from minus 1 to x is 4. So it's x greater than minus 1, x less than 4, between here and here. Any x values there will give this negative function below the line. Where is the function greater than 0? Well, that's from here, x less than minus 1 going this way, minus 2, minus 3, minus 4, and x greater than 4 going that way. It's this portion of the graph here. Okay, and if we plot we plot our g of x equals x plus 1 and find where does f of x equal g of x. Well, f of x equals g of x. One graph equals the other wherever they intersect. Okay, so that's this point and this point here, whatever those points are. And what about where is f of x less than g of x? Well, that's wherever the graph is below the line, okay? So those x values for wherever that graph is below the line, and that's between minus 1, x is minus 1, and x is, I think looking at the graph there, it's less than 5, not less than 4, okay? So it's the curved, where the curve is under the line, so it's from here, use a different pen. It's from here to here, and I think that's might be 5. Okay, so put 5 there. And let's have a look at cubic functions. So cubic functions take the form ax cubed plus bx squared plus cx plus d, and it's the same with respect to turning points and as the quadratics. But if a is greater than 0, the graph typically starts here and increases, and if a is less than 0, it starts and decreases. Okay. Any part of the graph above the x-axis is positive and any part is negative. This we refer to as increasing and then decreasing. Okay, DEC. Decreasing. Okay. So, if we were to plot x cubed minus 3x squared minus 2x plus 5 in the domain minus 2, x is between minus 2 and 4, that should be, then we would, with our calculator, just tap in the same again, we would get this set of couples or ordered pairs or coordinates, and if we were to plot that on a graph, we'd have this point, this here, here, and we'd have our cubic function. Okay, to find where f of x equals 0, that is, where does this cubic cut the x-axis, and that's at these 3 points here, minus 1, 1.2 and 2.2, and what about f of x equals 1? We just draw a line at y equals 1, and you see the x coordinates where that cuts, okay, and so on.